Welcome back to AgriTechSmart, where we explore the world of modern agriculture and technology shaping our future. Today, we'll take a fascinating journey through time, from the ancient rice paddies where farmers worked barefoot in the mud, to today's high-tech smart farms powered by drones and data. Rice is more than just food. It's the lifeblood of billions, the symbol of endurance, and the heart of cultures across Asia, Africa, and Latin America. Whether it's a steaming bowl of jasmine rice in Thailand or fragrant basmati in India, every grain tells a story, one of labor, love, and innovation. Rice cultivation began over 10,000 years ago in the valleys of China and India. Back then, everything depended on human effort and nature's rhythm. Farmers waded through flooded paddies, planting each seedling by hand, their reflections shimmering under the golden sun. These early methods relied on deep observation of the seasons. Farmers predicted rain by reading the wind, stars, and behavior of birds. Fields were plowed by buffalo, and irrigation was managed by simple bamboo channels. Despite being low-tech, these communities achieved remarkable yields through shared wisdom passed down for generations. Across Asia, rice wasn't just a crop, it became a way of life. In Japan, rice fields symbolized purity and perseverance. In Vietnam and Indonesia, entire festivals celebrated planting and harvest seasons. And in India, rice was seen as a gift from the gods, a sacred link between heaven and earth. Even today, traditional terraced rice fields in places like Bali or the Philippines stand as breathtaking reminders of that harmony between humans and nature. Sculpted mountainsides that turn into golden waves when the harvest comes. As the world's population grew, so did the demand for rice. The Green Revolution in the mid-20th century marked a turning point. Scientists developed high-yield hybrid varieties that transformed productivity across Asia and Latin America. Mechanization began to replace manual labor. Tractors, power tillers, and mechanical transplanters entered the fields. What once took weeks of backbreaking work could now be done in days. In countries like Japan and South Korea, innovation went even further. Fully automated systems, guided by GPS and sensors, could plant and harvest rice with almost no human labor. Meanwhile, Vietnam and Thailand balanced tradition with technology, introducing machines but still keeping the community spirit alive during harvests. Contrast that with sub-Saharan Africa, where mechanization arrived later. There, farmers are now catching up fast, adopting two-wheel tractors and low-cost irrigation pumps that have revolutionized small-scale rice farming. The gap between developing and developed countries is slowly closing as technology becomes more accessible. The journey begins with selecting the right seed, a crucial step that determines yield and quality. Traditional farmers often save seeds from previous harvests, valuing locally adapted varieties that resist local pests and suit specific microclimates. In contrast, modern farms use hybrid or genetically improved seeds, bred for high yield, drought tolerance, and pest resistance. In traditional rice systems, land preparation is done manually or with the help of animals, creating soft, waterlogged soil for planting. Farmers transplant seedlings by hand, a slow, careful process that requires experience and teamwork. The method may be labor-intensive, but it fosters strong community bonds and a deep connection with the land. Meanwhile, modern rice farms employ mechanical seeders and transplanters, dramatically reducing labor time and ensuring uniform plant spacing. Laser land leveling ensures even water distribution across large fields, improving growth efficiency. Fertilization has evolved, too. Instead of spreading by hand, smart applicators and drones distribute nutrients precisely where needed. Harvesting marks the climax of a farmer's hard work. Traditionally, rice was cut by hand using sickles, bundled, and left to dry under the sun. A slow but careful process still seen in countries like Vietnam, Cambodia, and the Philippines. In these regions, Manual harvesting allows farmers to select mature grains precisely and minimize waste. Modern farms, however, have revolutionized this stage. Combine harvesters, massive machines that cut, thresh, and clean rice simultaneously, can process hectares in a matter of hours. In the United States, Japan, and China, these machines are guided by GPS for maximum efficiency, reducing losses and labor costs. Interestingly, while modern techniques excel in speed and volume, traditional methods still hold value in mountainous or terraced regions where machines can't easily operate. In places like northern Vietnam or Indonesia's Bali terraces, human skill and hand tools remain essential, blending practicality with heritage. Once the golden fields are harvested, the journey of rice is far from over. After leaving the field, freshly cut rice, often called paddy rice, still carries husks, moisture, and impurities that must be removed before it becomes the polished grain we see on our tables. The first step is drying. Farmers or processing plants carefully dry the paddy to reduce its moisture from around 25% to about 14%. This step is crucial because improper drying can cause mold, spoilage, or broken grains during milling. In traditional farms, rice is sun-dried on open yards, while modern mills use automated dryers powered by clean energy, ensuring consistent quality and minimizing post-harvest loss. Once properly dried, the paddy moves to the milling stage, where advanced machinery takes over. The rice passes through cleaners to remove stones and debris, then enters the dehusking machines that strip away the outer husk to reveal brown rice. From there, it goes through polishers and graters, which smooth the grains, remove the bran layers, and sort them by size and color. Modern rice mills, especially in Japan, Thailand, and Vietnam, use optical sorters and AI-assisted sensors to ensure only perfect grains make it to packaging. This precision not only enhances quality, but also reduces waste dramatically compared to older systems. Finally, the processed rice is packaged and distributed for local and international markets. Some factories integrate smart tracking systems that monitor every batch, from harvest date to export destination, guaranteeing traceability and food safety. Byproducts like rice husks and bran aren't discarded. They're turned into biofuel, animal feed, or even biodegradable packaging materials. This circular approach shows how the modern rice industry is transforming traditional agriculture into a sustainable, zero-waste model. Sustainability is now the heart of rice cultivation's evolution. In many modern farms, precision water management reduces waste and methane emissions, while crop rotation helps maintain soil fertility naturally. Smart sensors, AI analysis, and remote monitoring are redefining what it means to farm responsibly. But perhaps the most inspiring aspect is how these technologies are empowering small farmers, giving them access to the same data, tools, and techniques once limited to large-scale operations. Across Asia, Africa, and beyond, digital platforms are teaching farmers when to irrigate, what nutrients to apply, and how to predict yields with remarkable accuracy. From the terraced paddies of centuries past to today's AI-driven mega farms, rice cultivation remains a powerful symbol of human perseverance and innovation. The balance between heritage and technology is what makes it so extraordinary, a partnership between tradition's wisdom and modern science's precision. Thank you for watching AgriTechSmart, where we uncover how innovation is reshaping agriculture, one crop at a time. If you enjoyed this journey into the world of rice, don't forget to like, share, and subscribe for more amazing stories from the fields of the future.